Good morning, students. Today we are going to discuss about the transformers third part. So in the first part we discussed about the introduction about the transformer, what is the basic principle of the transformer, how it is working. We are discussing about the transformer. In the second chapter, in the second part, we are discussed about the classification of the transformer, different types of transformers. So what is the working principle of the different types of transformers we discussed in the second part. In the third part we try to discuss about the remaining transformers and the losses of the transformers which affect the transmission of the power from the first coil to the second coil. Now we discussed about the constructional features of EHT transformer and necessity of shielding in RF choke and transformers. So that is the EHT transformer means extra high tension transformer. We are going to discuss about the extra high tension transformer. So it is also called live cut transformer or flyback transformer. Extra high tension transformer is nothing but a live cut transformer or flyback transformer. Generally this type of transformers are used in the TV receivers. These type of EHT transformers supplies the voltage essential for the picture tube of a TV set. For the TV picture tube of the TV set, the power supply is supplied by the extra high tension transformer. So this is the advantage of the EHT transformer. For portable black and white sets, this voltage is around 10,000 volts, 10 kilovolts, that is a 10,000 volts we need. In a large black and white sets, it can go from 16 kilovolts to the 18 kilovolts. 18 kilovolts we having the, so it can be as high as 25 kilovolts in color TV set. It can be as high as 25 kilovolts in color TV sets. That is, that much of high voltage is produced by the EHT transformers. Extra high tension transformers we are using. Constructional features of the extra high tension transformer. Now we try to discuss about the constructional features of EHT. In the last class we discussed about the different types of transformers. So in that, this is one of the specified EHT transformer. The EHT transformer consists of a set of independent coils wound over a ferrite core. That is, it having the set of independent coils, not a single coils. It having the some set of independent coils wounded over a ferrite core. Some units are fabricated like auto transformer. Generally it is used as a auto transformer. Other transformers have the EHT winding as a secondary coil. So some of other transformers having the EHT winding as a secondary coil. So this is about the high frequency. This is about the EHT transformer. So now we try to discuss about the radio frequency shielding. Radio frequency shielding. Radio frequency chokes and transformers are required to encase in a metal cover of either copper or aluminum to provide a shielding against the varying flux of radio frequency currents. The shielding covers not only isolates the coil from externally varying magnetic field but also minimizes the effect of the coil's radio frequency currents on external circuits. So that is the importance of the radio frequency shielding. We need to provide a shielding of for the coil. The RF chokes generally, the RF chokes and transformers are required to encase in a metal cover of either copper or aluminum. It may having the metal cover to protect, to provide a shielding against the varying flux of radio frequency currents. So for that purpose, these chokes and transformers are encased in a metal cover. That cover may be made up of with the copper or aluminum. So this type of shielding cover not only isolate the coils, they are not only isolate the coils from externally varying magnetic field, but also minimizes the effect of the coils radio frequency currents on external circuits. So next topic we are going to discuss about the object. Next topic is specification of the transformers, application of transformer, losses in the transformer. So in this class we try to discuss about in detail about the what are the different specifications of the transformer. So what are the different applications of the transformer and what are the losses in the transformer. Generally you know that specification means specifications of a component which gives the total description of the device. The meaning is what is the voltage rating, what is the current rating, what is the power rating, where we need to use, what type of core is there, what type of winding we are using. So like this all the data is given by the specification. Whenever we want to use a transformer, then we see the specification of the different transformer, which specifications are matches with our application. That particular specified transformer will be chosen so that we can minimize the cost and we also minimize the losses of our application. So next about the applications of the transformer. So what application of the transformer means, where these transformers are using, where this type of transformers are using, that is called as the applications of transformer. Losses in the transformer. So what are the losses in the transformer? What are the different types of losses we having and how we are going to minimize those losses? If we know that, we try to reduce those losses whenever we are using that type of transformer. Now we try to discuss about the specification of transformers. You can see the specification of the transformers. What are the important specification we need to consider is a signal transformer or communication transformers are usually rated by their. The thing is, if we use the signal transformer or communication transformer, so those transformers are usually rated by their current rating, power rating, and input output impedances. Current rating, power rating, and input output impedances and the frequency range. So these are the some of the specific ratings of the transformer. So here what this current rating says, that how much power, how much current can be passes through these coils. So that is given by the current rating. Power rating is what is the maximum amount of power which can transfer through the device. That is indicated by the power rating. Input and output impedances. What impedance is offered by the transformer, primary winding and the secondary winding. So that is given by the input output impedance. And the frequency range. So in which range this type of transformer using, that is called as a frequency range of the transformer. Now next we try to discuss about the another type of transformer, power transformer. Power transformers are rated by their primary and secondary voltages and power capacity, that is volt ampere capacity. Generally power transformers are rated by their primary and secondary voltages, power capacity, that is volt ampere capacity. Applications of transformer. So power transformers, where we are using this transformers, power transformers. Power transformers are used in power supplies of various electrical and electronic circuits such as radio, TV, refrigerator. So these are the very important, very important applications of the power transformer. Generally in any device we need to have a power transformer. This power transformer will matches the power requirement of our home appliance value. That is, power transformers are used in power supplies of various electrical and electronic circuits such as radio, TV, refrigerator. So in the radio we having a one type of power transformer. In the TV we having the power transformer. In the refrigerator also we having this power transformers. The next transformer applications are audio frequency transformer. So where we are using this type of audio frequency transformer. Audio frequency transformers are used in audio stages. So where the audio signal is transferring, that place we use this audio transformers. So generally these transformers are used in at the amplifiers, in the radios and in the TVs. At the amplifier stage, in the radios, in the TVs, we are using the audio frequency transformers. The next transformer is the radio frequency transformer. So generally this radio frequency transformers we are using at the tuning circuits of the radio. Tuning circuit means these tuning circuits tune the frequency or adjust the frequency of the radio and TV. So for that purpose we use these radio frequency transformers in the tuning circuits of the radio and in the TV. Another type of transformer is the intermediate frequency transformer. So generally this type of transformers are used in communication receivers. At the receiver stage we are using this intermediate frequency transformer, that is radio, TV, etc. The next one is the pulse transformer. So where we are using this type of pulse transformers. So generally these pulse transformers having the important role. So these pulse transformers are used to trigger the thyristor like SCRs. So whenever you want to trigger a thyristor components like SCR, triac, diac, we are using the pulse transformer. This pulse transformer used to trigger the thyristors, and also we use this pulse transformers to change the amplitude of the pulse. If you wanted to change the amplitude of the pulse, the meaning is step up and step down. The magnitude is increases or decreases by using this transformer without changing the frequency. So that is the advantage of this transformer. So we can change the amplitude of the pulse by using the pulse transformer. So another one is invoke the polarity of the pulse. Invoke the polarity of the pulse means if we wanted to invoke the pulse polarity, we can use the pulse transformer. The last one is the EHT transformers. EHT extra high tension transformers. Generally, these transformers are used in the TV receivers. So these are the applications of the different types of transformer. So generally these are related with the communication related transformers, but in going to the electrical field, the transformer is very useful in the stepping up and stepping down the power supply which is generated from the power generations. From the power generator we will generate the particular voltages. So in order to transmit that voltage we need to convert into the high voltage. So there we need to step up the voltage. Coming to at the load side, at the domestic purpose we use the low voltage we are using. So at that point the transformer is used to step down the high voltage into the low voltage. So these are the applications of the transformers. We may having the so many areas are there, but we discussed about the some of important applications. So now we try to discuss about the next topic, that is the losses in transformers. So what are the losses? What are the losses in the transformers? So losses, as we know that the transformer does not have any rotating part. We already says that transformer is the static device. Transformer is the static device. So the transformer does not have any rotating part. There is no friction and windage loss. So if we don't having any rotation part, there is no friction loss and no windage loss. That is the advantage of the transformer. But transformer suffers from two types of losses. The loss is copper loss and the core loss. First one is the copper loss, second one is the core loss. Now we try to discuss about this copper loss and the core loss. So what is the copper loss? What is the copper? The copper loss. So copper loss is nothing but the I square R losses in the copper windings caused by the current flow in them. So this type of losses are called as the copper losses. It is reduced by selecting thicker gauge wire for the windings. So what is the meaning of copper loss? Means the copper losses are called as the I square R losses. That is because of the winding resistance, because of the windings opposition while flowing through the current, some sort of energy is losses across the winding. That losses are called as the copper losses. The I square R loss in the copper windings caused by the current flowing in them are called as the copper losses. How we can reduce these copper losses? These copper losses can be eliminated or reduced by selecting the thicker gauge wire for the windings. For the windings, if we use the thicker gauge wire, we can reduce the copper losses. The next type of loss is the core losses. So what is the core loss? So generally the core loss means because of the core material we may having the some sort of energy lost in the core. So what are the different types of losses? Is in the core we having the three types of losses are there. First one is the flux losses, second one is the eddy current losses, third one is the hysteresis losses. Flux losses, eddy current losses, hysteresis losses. These three losses are occurred because of the core loss, because of the core. These three losses are called as the core losses. Now we try to discuss about these losses in detail. The first one is the flux loss. What is the flux loss? The flux loss. This loss is caused when all the flux lines associated with primary winding of a transformer does not pass through the secondary winding. So when we get the flux losses means what are the flux is induced at the primary winding, that flux does not link with the secondary winding. So then some sort of flux will be erased or not going to cut the secondary coil. So that amount of flux may be lost. So this is called as a flux losses. This loss is caused by when all the flux lines associated with the primary winding of a transformer does not pass through the secondary winding. So this is called as a flux loss. Simple way you can say is that if any sort of the flux is not linked the secondary winding, so the not linking flux is called as the flux loss. Next one is the eddy current loss. Next one is the eddy current loss. This loss also called as core loss. Eddy current loss. This loss is caused by the flow of small local currents due to the induced EMF in the core. Eddy current loss is nothing but a small local currents due to the induced EMF in the core. So for this only what we are doing is this loss is reduced by using steel of high silicon content for the laminated core. So the meaning is if you don't use the laminated core, what happen means whenever flux is induced in the core, because of this magnetic flux, some sort of a small amount of current is induced in the core. Whenever small amount of current is induces, so that induced current may cause the power loss. That power may be in the form of the heat. In order to avoid this eddy currents, what we are doing is we use the laminated core. Not we can use a single thick type rod type material. We use the laminated core, that is high silicon content for the laminated core, so that we can eliminate or reduce the eddy current losses. This eddy current losses is caused by the flow of small local currents due to the induced EMF in the core. This loss is reduced by using steel of high silicon content for the laminated core. The next one is the hysteresis loss. A small amount of energy is lost each time alternating primary current is reversed. This is reduced by using suitable core materials like soft iron and silicon steel. So already we know that what is the hysteresis loss means whenever the alternating flux moving from the positive cycle to the negative cycle and negative cycle to the positive cycle, after positive cycle to the negative cycle, some sort of energy may lost because of this alternating current. So this type of losses can be reduced by using the soft iron and the silicon steel type material. If we use, we can also reduce this hysteresis losses. That is, a small amount of energy is lost each time Alternating primary current is reversed. This is reduced by using suitable core materials like soft iron and silicon steel. So these are the losses in the transformer. We don't having any rotational and windage losses. Friction losses are there in the transformer because of it is a static device. But we having the two types of losses are there. First one is the I square R loss. Second one is the core loss. The I square R loss because of the current flowing through the inducting wire. So that is caused because of the inducting wire problem. So that can be eliminated by using the thick windings. We can eliminate the I square R. Coming to the hysteresis losses, we having the three type of losses are there. First one is the flux loss. Second one is the eddy current loss. Third one is the hysteresis loss. Coming to the flux losses, the thing is the maximum whatever the amount is induced at the primary coil, if it is not linked the total with the second coil, that is called as the hysteresis. That is called a flux losses. What we need to do is we need to use the proper core to link the total induced flux with the second coil. The second one is the eddy current losses. The eddy current loss is nothing but whenever flux is induced in the core, a small amount of current is induced in the core. So whenever the small amount of current is induced, I square R power may dissipated as a heat in the core. So in order to avoid this type of I square R induced eddy current, we can use the high silicon content laminated core. We can use laminated core. We can use so that we can eliminate the eddy current loss. The next one is the last one is the hysteresis losses. The hysteresis losses is nothing but each time the alternating current moving from the positive to negative, negative to positive, some sort of energy is lost here. So this type of loss is called as the hysteresis losses. Hysteresis losses. Now hysteresis losses, we can eliminate this hysteresis losses by using the soft iron materials as a core. So like this we can eliminate the or minimize the core losses. Next we try to discuss about common faults in inductors and transformers. So what are the different common faults occurs in the transformer? Now we try to discuss about these things. What are the common faults in the inductors? The main common faults in inductors and transformers are: first one is the open circuit. Open circuit means if the switch is open, that is the current is not flowing from the first terminal to second terminal, that is called as a open circuit. That is, the open circuit means it is caused by excessive current or undue mechanical stress or severe temperature cycles. That is called as a open circuit. Open circuit. So why open circuit is occurring means the open circuit is caused by excessive current. If the excessive current flows to the winding, it may try to damage the inductor, so it may act as a open circuit. Excessive current or undue mechanical stress. If you apply more mechanical stress on the inductor or transformer, it may behave like a open circuit. Or severe temperature cycle. If the temperature is increasing and decreasing, So that also causes the open circuit. The next one is the short circuit or partial short circuit. Short circuit or partial short circuit. It may occur when enameled wire becomes too hot and causes enamel to melt and thus causing for the turns to be shorted. So that is called as a short circuit or partial short circuit. Whenever we are using this copper wire to make the windings, what we are doing is we enameled this wire so that one winding does not short with the another winding. This enamel protect the winding from one turns to another turn without having any short circuit. But so this is happened because whenever the more amount of heat is or more amount of temperature is applied, this enameled may melted. Whenever this enameled melts, what happens means the first turn touches with the another turn. So the two copper turns are touches, what happens? It becomes a short circuit. Whenever turns are short circuited, automatically the device may goes to burn or damages. The device becomes damaged device. So what is the meaning of short circuit? Means the short circuit may occur or partial circuit may occur when enameled wire becomes too hot. Enameled wire becomes too hot and it causes the enamel to melt. Then thus causing for the turns to be shorted. Because of the melting of the enamel, the turns to be shorted. So that is called as the short circuit or partial short of the inductor or transformer. Next one is the losses of insulation between core and the windings. Loss of insulation between core and the winding. The meaning is in the between core and the winding, if the insulation losses means whenever we wound the coil on the core, we need to provide some sort of insulation. If it is losses that insulation, we may having the some faults are there. If core is broken due to mishandling, it will cause an air gap to develop. What happens? Because of our mishandling, if that core is breaks, what happen means if the core is breaking due to the mishandling, it will causes an air gap to develop. It will causes the air gap. This will reduce the inductance and so the current increases. When the core breaks, what happens? The linkage of the flux will be reduces. If the flux linkage is reduces, what happens? Inductance will be decreases and the current is increases. This increasing current causing for the melting of the enamel. If the current is increases, enamel will be melts. After melting this enamel, what happens? The winding may become the short circuited. So this is the fault of the core because of loss of the insulation between the core and the winding. If core is broken due to mishandling, it will cause an air gap to develop. This will reduce the inductance and so the current increases causing for the melting of enamel. Next one is the next fault is increasing in the value of inductance. What is the meaning? The meaning is high temperature may causes increase in the dimensions of an inductor. High temperature may causes increasing in the dimensions of an inductor. This will result in increasing in inductance. What is the meaning of this increasing in the value of inductance? Means if we apply the high temperature, the winding may having the increasing in the dimensions may increases. If the inductor dimension increases, what happens? Automatically inductance will be increases. This is also a fault of the transformer or inductor. High temperature may cause increasing in the dimensions of an inductor. This will result in increasing in the inductance. The next one is leakage between windings or between winding and the core. Leakage between the windings, if may having the leakage between the two windings or between the winding and the core, that is also a fault of the transformer. So when it is happens means whenever the enamel melts, this this type of leakage will be occurred in the transformer. It occurs due to melting of insulation point. Another type of problem is loose core. If the core is loose, it results in electrical noise due to vibration. If the core is loose, what happen means we may having some sort of electrical noise is generated. So we need to have the tight core. Next one is the saturation. Saturation means presence of DC in addition to AC. Presence of DC in addition to AC causes saturation of the core in chokes and transformer. If the DC is presented in the AC, what happens means this is also a fault which makes the transformer at the saturation. So these are the some sort of faults which we are discussed in this class. We discussed about the different types of faults regarding the transformer and inductor. Once again, we try to discuss about the last classes about the transformer. What we discussed in the last classes, we try to see the transformers can be classified into different groups and types based on the following factors. Types of core which we are using: core type, shell type, berry type, spiral type. These are the four types. Method of cooling we are using: natural cooling, artificial cooling with water, mixed cooling transformer. So these are the different classification. This is further we having the knowledge about these transformers. As for transformer ratio, 1:1 transformer, step down transformer and step up transformer. Based on the number of phases also we having the transformer: single phase, two phase, three phase. As for winding connection also we may having these transformers: star to star connected, star to delta connected, delta to delta, delta to star, open delta, Scott connected. As for the size of the transformer: distribution transformer, power transformer. Based on function and utilization: auto transformer, potential transformer, current transformer. Like this, in the practical we may have so many types of the transformers are there. Now we try to see some of the practical transformer. So what are the parts are there? You can see this is the parts of the transformer: flange for radiator assembly, LT side, conservator tank, relay. Like this, we having the some sort of parts are there in the practical transformers. You can see another type of practical transformer, that is the HT termination, core, LT termination, HT winding, tapping of the windings. So like tapping also very important for the transformer. You can see the insulation of transformers was what are the insulation we are using. Two main kinds of insulations are there. Major insulations may insulating cylinder between LV and core, also between HV high voltage and low voltage, insulating batteries between limbs, coils and core yoke. Oil impregnated paper used as its high dielectric strength. We are using this type of insulating materials. So minor insulations also there. Insulation between the individual turns, between layers, conductor insulators, paper or cotton we may use. Air insulated transformer, insulation used is a glass tape. We may have like that. So now we try to see. We can having the another you see practical tapings how it is. So we having the main two locations. Tapping operation is there, inside tank, outside tank is there. Like that you can see the diagram. So what we need to see about this transformer operations, like this. We having the different tests also there in the practical type. Routine tests are there, and different tests are there. Ratio and polarity test, load losses, impedance measurements, insulation resistance, resistance of windings, no load losses, no load current, voltage test, separate source test, induced voltage, coarse insulation test. So like that we having so many type of are there. We may having this characteristics also there. Transformer oil, we use the transformer oils. So why we are using this oil means this oil shall be clear and transparent and free from the suspended matter of sediments. So this oil is used for the cooling the transformer. Like this we're having the some sort of characteristics you can see. So these are the practical transformer standard specification. So transformer, different oil brands given. So what are the different tests we need to perform on the transformer. So drying of transformer, you can see humming sound of the transformer. Why we are getting this type of humming sound? This is the one of the basic problem of the transformer. Humming type transformer. Humming in the transformer is a sound which is produced due to the vibration of the core in the transformer. Vibration of the core in the transformer. Because of the core vibration, this type of humming sounds are generated. Humming in the transformer is a sound which is produced due to the vibration of the core in the transformer. The vibrations are produced due to the change in the polarity of an alternating current or voltage and by the losses of lamination of the core. Both can be minimized by tightening the core of the transformer. We already discussed about this type of loose core loss. Whenever core is loose, what happened means some sort of humming sound is generated. This is also some of the fault. So these vibrations are produced. Why these vibrations are produced? Due to the change in the polarity of an alternating current or voltage and by the losses of lamination of the core. These losses of the lamination core or this change in the alternating current both can be minimized by tightening the core of the transformer. If you tight that, we can eliminate the humming sound of the transformer. So generally in the practical we can see this type of sound at the transformer at the pole. We can see the sum of humming sound. So why this humming sound means because of that core is loose. If you tight the core, this type of sound may reduces. This type of sound may reduces. So now we may have so many things are there not needed for us. We can see short circuit and core balance test, we see ratio test, short circuit test, we may have insulation test. So our transformer oil testing also there. Why I am showing me, so in order to understand what are the practical things we may have. Already we discussed about the iron loss or core loss, copper loss or I square R loss, stray and dielectric loss, we may have these two. So another resistance losses also there, resistance of the winding, copper loss we can say, eddy current and hysteresis in the iron parts and core, losses due to the leakage resistance, we can do that leakage flux. These are the some of the losses in the transformer. For it so many of there, we can having the general of things on conditions leading to faults. What are the different conditions which may get the faults in the transformer? So we will already discuss insulation breakdown, aging of the insulation, overheating due to over excitation, oil contamination and leakage, reduced cooling, external circuit fault. So these are the some major faults causes in the transformer, that is insulation breakdown. If the insulation breaks, that may lead to the fault. Aging of the insulation, major one is insulation should be not damaged. So these are the different parts we have. So we may discuss of this one. So we may have so many types of there. So like this, these are the practical things which may occur whenever we are using the transformer. So these are the different things which we discussed in this class. We discussed about a remaining topic of the classification of transformer and application of the transformer. We discussed the application of the transformer and the specification of transformer and losses in the transformer, and we also discussed about the faults which are occurring in the transformer in this class. Thank you. Now we can stop this class. Thank you.